This is 2.3, information from the graph. We've already talked about graphing functions and several aspects about it. So now let's talk about the interpreting the part of the graph. So on this example, I have the temperature graph, and notice it's hours since 12 p.m. And notice this is a temperature in Fahrenheit and each of them are tens of degrees, so 10, 20, 30, 40, so forth. So here I want to know at the temperature at hour 1. So at hour 1, notice at hour 1 it happens to be about right here, and that would be at 50 degrees. At hour 2, that would be about 55 degrees. Hour 5, that would be right here, back down to 50 degrees. So the values of X where the temperature is 40 degrees. Well, 40 degrees is right here. And so the times where it meets at would be there, here. It starts dropping below that. So really just those 3 points. So this first one is kind of not 100% sure just by looking at the graph. So I would just say it's right around like 12:20, 12:30, somewhere right around there, because it's a little bit right around the halfway mark. And again, since 12 p.m., so this would be 1 p.m. So right around 12:20, 12:30, I would take that. Again, we're just interpreting the graph without doing any algebra, just interpreting it. And it would also meet at 6 o'clock and 7 o'clock. So, and then also the net change between 1 p.m. and 6 p.m. Well, 1 p.m., the temperature we already said was at 50 degrees, and the temperature at 6 p.m. Is back down to 40 degrees. So the net change would be 10 degrees between those two times. So let's look at this function right here. First, I want you to graph it and then tell me the domain and the range. Well, to graph it, you make an XY chart. And then you select values, just randomly select values, but notice you can't have negative numbers inside of a square root. So really, we're just talking about -2, -1, 0, 1, and 2. And of course, you can always plug in decimals and fractions in between those values, but you're just going to graph those values, plug them in, and then come up with the graph. And then -2, 0, -1, about 1.7, 0, 2, 1.7, and then 2, 0. So literally the graph would look like this. And then the domain, remember the domain is a set of X values. So we're talking about from -2 to 2. Notice it has brackets because they're closed. The range is a set of the Y values. So look at the minimum and then also the maximum. So this would be from 0 to 2. Again, with brackets that it includes that. All right, so let's solve this algebraically and graphically. So algebraically, we would just bring everything over to one side. And then we would solve that by using like factoring, completing the square, quadratic. We would solve that in one of those fashions. It actually does factor, so we would end up getting x equals -1/2 and x equals 3. So again, you can use the quad if you want, or completing the square, but you're going to end up getting those two values. So now, how do we solve it algebraically? Well, algebraically, if you focus on, let's focus on the left side, and so let's just call that f of x equals 2x squared plus 3, and let's call the right side g of x. And graphically what it means is you have a function on the left side, you have a function on the right side, and you want to know where they meet at. So where will they intersect at? And that's what we're trying to find. So we're going to graph the red one, we're going to graph the blue one, and we're going to find out where they meet using the graphical method. So notice I graphed the red and I graphed the blue. I found out where they would cross at. Something I do want to point out, looking at the XY charts, you can literally see -1/2, 3.5, -1/2, 3.5. So notice that's what matched. I knew X, they would match at -1/2. And then X equals 3 is what I found for the other solution. So 321. So a big suggestion is to you, once you solve it algebraically, make sure these points right here, make sure these points are included as your input for your x, and then that way they'll match up on the XY chart. All right, so let's look at this function. What we want to do is graph it. We want to find the domain and range, and then we want to find the intervals of where the function is increasing and decreasing. So this is a rather large function, so you're going to have to do like an XY chart and plug some numbers in and use a little bit of scrap paper to be able to do this, to be able to make your XY chart and get those values. So notice I made an XY chart, I graphed it, and then that's letter A. Now the domain and the range, so the domain is the set of numbers on the X line that I can plug in, which is all real numbers. So this is negative infinity to infinity. Now the range, notice it's all the way, it keeps going down forever. So the range is, the lowest point is negative infinity, but notice the highest value that it gets to is, I actually found it right there. It goes all the way to 32. All right, now the intervals of increasing and decreasing. So if you notice, we always start on the left-hand side. So notice the left-hand side. So it's increasing, increasing, increasing until it gets to -1 here. So once it gets to -1, and then it starts changing. And then, so I know it increases from negative infinity all the way till it gets to -1. Again, on the X line, at X is -1, okay? Then it all of a sudden changes directions. So then it starts decreasing from -1 all the way to 0. So -1 to 0, it starts decreasing. And then all of a sudden it increases from 0 all the way up to where X is 2. So it starts increasing again from 0 to 2. And then all of a sudden it starts to decrease from 2, and it keeps decreasing. To be able to do that. So notice the increasing, decreasing functions. You have to look for the turning point. By the way, that's positive infinity, because again, we're talking about the X line. So from -1 to 0, from -1 to 0, it decreases, the black does. And then from 2 on the X line, 3, 4, 5, 6, 7, 8, 9. When X is 9, when X is 10, when X is 11, the function is still decreasing. So this is talking about the X value. So it keeps decreasing all the way. So that's the intervals of increasing, decreasing. We also found the domain and the range, and we also graphed it as well.